Welcome, Tirthankar Lahiri and Markus Kißling. I'm looking forward to talk to you. Please give your short introduction. Tirthankar.
Okay. Thank you. Thank you for having us. My name is Tirthankar Lahiri. I'm the Senior Vice President in Oracle Database for a team called the Data and AI Engines Group, and I'm responsible for things like database in memory and more recently AI vector search.
Okay. Markus?
And I'm Markus Kißling. I'm a product manager for In-Memory, database in memory, and AI vector search in Tirthankar's team.
Vector databases are currently a hot topic, and you brought out a product, AI vector search. Please give a short introduction about the features.
Sure. I'm very excited about this new technology. It's actually not a new product. It's a new feature of the Oracle Database 23 AI. It consists of a few components. So first of all, the ability to convert unstructured or complex data into vectors, which are basically lists of numbers, and then being able to store them in the database using a new vector data type, being able to index them using sophisticated new vector index technology, and then being able to query those vectors for similarity searches, finding similar vectors that match a certain search term using very simple, intuitive SQL. Markus, anything to add to that?
It's quite easy to start with AI vector search. It's only, as Tirthankar mentioned, the new vector data type and SQL functions. And then you're ready to go.
How can people learn about the new features, about the new components?
For example, we had yesterday our workshop at DOAG, and within, let's say, 10 minutes, you learn what the vectors are, how to create table with the new vector type, how to insert vectors, how to work with embedding models, how to do the similarity searches, and let's say you are able to work with the new capabilities of similarity search.
How does the similarity search compare to the full text search, for example?
That's a very good question. So that's actually the beauty of vectors. Vector essentially is the distillation of the meaning or the semantics of data. They don't actually represent the contents, but they're like the essence of the data. And once you create vectors, then you can compare the vectors by distance to see how far apart they are. Things that are more similar, like dog and cat, will have vectors that are closer together than, say, dog and New York, because there are two different words that mean totally different things. So that's the basis of similarity search. You look at the vectors that are closest to the vector for your search question. If you have a question or a term you're looking for, you convert that into a vector, and then you just look at the vectors in the table column to see which ones are the top k closest vectors to your vector space. So it's extremely simple. In terms of SQL, it's almost trivial to adopt. As Markus said, it literally is a 5 to 10 minute exercise to explain the basics to somebody for how to use it. We have a ton of information about how to use it on oracle.com, but anybody who has any SQL background can become proficient in 5 minutes.
Now I have stored the vectors, I can search for them, but why do I then need indexes? What is the benefit of creating indexes? And there are also different forms of indexes.
Yes. I'll take a quick stab, Markus, then I'll hand it over to you. So indexing for vectors is very simple. You need it for speed. If you don't care about speed, don't index. That's simple. Because you could find the top k matches just by looking at all the vectors, which would give you a top k, but would take a long time because you have to look at every vector in the column. What the vector index does is it compromises search accuracy slightly, but gives you more than 100x speed up in actual retrieval of the top k. And we index essentially to reduce the time required to find the top k. And the index are designed to sort of eliminate false matches. They do their best to find the actual top k, and they get very close to that. And we measure that accuracy using a metric known as, I think the literature called the recall. We call it accuracy. Markus, you want to talk about the index types we have?
We have the In-Memory-Graf-Index. This is the fastest index we have. Yeah, it's in the database, in the SGA, in the vector memory pool. And then we have the IVF-Index. They are on disk. and you have, let's say, clusters of values which we have put in partitions, and they grow. What's it called? There's no limit. Yeah.
Yeah. So for data that fits in memory, you can use the In-Memory-Graf-Index. For data that does not fit in memory, is very large, you can use the IVF-Index, which can scale to unlimited sizes using partitioning.
So what are typical use cases for vector databases? When do people or enterprises use a vector database?
That's a good question. I mean, again, this is still early stage, so use cases are developing and evolving. We have seen a lot of different types of use cases, broadly classifiable as two categories. One use case is simply doing similarity search, finding similar things. So one thing is I've seen customers do is to find similar support incidents, or find similar products, or find similar customers to a certain profile. So because vectors enable this type of search, which you couldn't express easily in SQL before, now you can find similarity through vectors. The other category is in generative AI, where the vector database is used to augment interactions with large language models. And those tend to be things that involve documents and speech and so on. So things like internal or external chatbots that you can interact with for, say, support purposes and so on. We have an example of a customer, I think, that has tried and successfully created an online travel chatbot to recommend travel itineraries and flights and so on. One use case with LLMs that vector databases have been used for is to help to classify documents. Many institutions have gigantic numbers of documents stored all over the enterprise to classify, summarize which ones are contracts, which ones are legal briefs, etc. That's another use case we are seeing a lot of, just to make sense of the document corpus that the enterprise has. But like I said, it's early stage. There's all kinds of exciting use cases. I'm seeing Oracle being used for things that I hadn't expected before. Like I think in the keynote, Juan mentioned, detecting genome sequences and finding match with existing bacteria, infection detection, etc. It's a use case I'd never imagined Oracle database being used for. And that's the kind of use case that vector databases now make possible.
Currently, there's quite a hype about vector databases, and as other vector databases exist. What do you think are the strengths of Oracle AI Vector?
Well, okay, I'll try to answer to the extent I can. Let Markus answer the rest. The vector data, first of all, vector technology will become mainstream in the next 5 years. It's not going to be unique to any database any longer. It'll be like supporting B-tree indexes in any database, for instance. The big advantage of Oracle's vector search is it can be combined with business data search. For enterprise applications, you typically aren't simply searching vectors. You're also filtering on relational attributes. You're looking at customers that live in a certain city or location when matching their photographs. That is what Oracle excels at, because we have the world's business data. Now you can add vectors to that data and combine those searches with relational searches to get the most powerful searches possible. And that's really the Oracle differentiator in terms of vectors and business data. Markus, anything to add to that?
The vector type is, as Tirthankar mentioned, is only a data type. It's not a complete new database. And this is Oracle. Yeah, this is part of the kernel. This is not, let's say, a new product. It's Oracle. And this makes it so fast to adopt new use cases. Customers have new possibilities. They can leverage their business to the AI, let's say, what's it called? AI age of intelligence, artificial intelligence, with their with their old knowledge, with their, let's say, with use cases, with documents they have, and leverage it to new possibilities.
Yeah.
So you just create a table with a vector type, and as you said, you can also store the business data as you are used, for example, text or integers or such data.
You can vectorize everything. Yeah? You can vectorize documents, string columns. You can vectorize, as Tirthankar mentioned, audio files, video files, get a vector out of it, compare it, get the similarity vectors, and then you are done. That's it. It's pretty fast with Oracle.
Yeah. So now let's have a outlook into the future. What do you expect to come in the next years in the field of AI vector search?
I think we're going to see a lot more advancement of RAG technologies, retrieval augmented generation. I think Oracle database will play a critical role there because, again, as the world's business data custodian, a lot of RAG pipelines will involve Oracle database. And RAG combined with things like microservices, agentic workflows, etc., you'll see more and more of in the future. This is the beginning of like a new age, essentially. This is not something that, this is not just a passing fad. This is real. And every single enterprise that I speak to is trying to investigate or future use cases. They have already several use cases in mind already, but the space is evolving rapidly. And I think we're in for a very, very fun ride in the future. It's really the age of AI, as Markus was saying, and AI combined with data. So, for us, at Oracle, it's all about AI for data. So that's really what you're going to see much more of, how to deeply integrate AI into business processes. I think, and the vector database will be a foundational technology that will enable that. Does that answer your question?
Yes, definitely. Many thanks for your insights, Tirthankar and Markus.
Okay.
Thanks a lot.
Thank you. Thank you, Andreas.